Hello everyone, welcome back to my YouTube channel. Today we are going to discuss Routh-Hurwitz criterion for stability. In last class we learned what stability of a system means. It is basically that all the poles of a system, that is the characteristic equation, the roots of the characteristic equation basically lies on the left half of the S-plane. If there is anything on the right half of the S-plane, it is called an unstable system. If the poles lie on the j omega axis, then it is called a marginally stable system. Now let's consider Routh-Hurwitz criterion. Here we prove the stability of the system by basically creating a Routh array. In order to do that, first we consider a characteristic equation of the system. I have written a characteristic equation here with the power s raised to 7. Okay. Then we'll learn how to write the Routh array. So I'm starting with the first column, that is I am writing the powers of s until s raised to 0, from s raised to 7 to s raised to 0, one after the other inside a column. Then I'm going to write the coefficients on the, I'm starting the coefficients. So I am considering the first coefficient, that is a0. A0 is the coefficient of s raised to 7. So I'm considering the first coefficient a0 and I'm writing it as the first term. Then I'm writing the second coefficient a1 just below a0. And I am writing the third coefficient, that is a3, on the next column. And in a somewhat like a zigzag manner, I am writing the coefficients. Okay. Then from this we have got two rows our Routh array. We have got our first two rows of our Routh array. Now we have to find the next row, that is the third row. So we don't know what are the elements of the third row. In order to find them, we use a equation. So in order to find B1, what we do is we consider the two columns above it. Actually, we consider the two rows. In order to find the third row elements, we consider the two rows above it. Similarly, if we are doing it for the fourth row, we will consider the two rows above it. That will be the second row and the third row. Okay, so what I'm going to do is I'm going to find B1. In order to do that, I'm multiplying A1 with A2. Multiplying A1 with A2 and subtracting A0, A3. Multiplication and dividing this with A1. I'll get B1. Similarly, in order to get B2, what I'm going to do is I'm going to consider the first column as itself, and then I'm going to consider the third column instead of the second. So I will consider the third column, and what I'll be doing is I'll be doing A1, A4 minus A0, A5 divided by A1. Okay, now for the next term, that is B3, I'll be considering the next column. That is A6, A7. Okay, I'm considering. So what I will be doing is A1 into A6 minus A0, A7 divided by A1. That is doing this and this multiplied and divided by A1. Okay. So by this we got the three terms B1, B2 and B3. Similarly, we'll do this with the coming rows, the following rows. I will also do C1 as well in order to get a better understanding. C1 will be, what I'll be doing is I'll be considering, in order to find C1, I'll be considering the two rows above it. Okay, the two rows above it, that will be A row, one A row and a B row. Okay, so I'm considering the first column, that is A1 and B1. I'm considering A1 and B1. What I'm going to do is A1 and B1, and the first in the second column we are considering those two, and we'll be getting B1 A3 minus A1 B2 divided by B1 as the C1. Similarly, we will go with C2. In order to do C2, what we will be doing is be considering the next column. That will be A B1 A5 minus A1 B3 divided by B1. Similarly, we can also find C3, and with that we will get the fourth column. Then after that we will move on to the fifth column. So in order to find D1 and D2, we will be considering the two rows above it. It's a chain and it will end with a single answer. Okay, this is how you solve a Routh array, and you will solve it like this, and you will end up like something like G1, some kind of value. And after this, how will we determine the stability, whether the system is stable or not? It is basically simple. If the first column of the Routh array, if the first column, that is this one, is the first column of the Routh array contains elements which are all positive. That is, the first row contains positive elements, then it means it is a stable system. That's how you identify stability of a system by using a Routh-Hurwitz criterion. So now that we have discussed what Routh array criterion is, we'll be doing some problems on Routh array criterion, and that will be okay. So problem, we are doing our first question, that is s raised to 5 plus s raised to 4 plus 6s cube plus 12s square plus 18s plus 6. Check whether the given system is stable or not. I'm so sorry, I will be writing one more question with this. So s raised to 4 plus 8s cube plus 18s square plus 16s plus 5 equal to 0. Okay, I'm gonna do the second question first. Answer to the second question, that is how first of all we are gonna write the question once again. S raised to 4 plus 8s cube plus 18s square plus 16s plus 5 equal to 0. Now what I'm gonna do is I'm gonna start writing the Routh array. So I'll write the powers of s first, that is starting from s raised to 4, the highest power. I'm going down to s raised to 0. Okay, now I'm writing the coefficients in a zigzag manner. So I'll start with 1, 8, 18, 16 and go to 5. Okay, then this term, there is no such term, so I can either put 0 or just leave it like this. Okay, so next we are going to find what is to be written here. That's b1. In order to do that, we'll multiply 8 into 18 minus 16. 16 into 1 is 16 divided by 18. What will we get? If we do that, we will get 16 as the answer. So I'm actually writing 16. Okay, then in order to find the next element, we are going to do is, what we're going to do is, we'll multiply the first to this with the next row, next column. So it will be like 8 into 5 minus 1 into 0, so 0, divided by what is here, it's 8, so it will be 5. So this term is 5. Okay, then we'll we'll find the elements of the next row. So in order to find the elements of the next row, what we're going to do is, we are going to do the same rule, that we'll consider the two rows above it, and we'll do the same thing that we have done earlier. So I'll do 16 into 16 minus 8 into 5 divided by 16, and by doing this I'll get 13.5. so I'm writing it like that, 13.5. okay, then there is no term to multiply with, so there won't be any other term in that particular row. There won't be any other term other than the 13.5. okay, now I'll move on to our next row. So in order to consider the next row, we'll consider the two rows above it as usual, and what we'll be getting is pretty easy. I'll explain it. This is quite easy for us to understand this. This is actually a very easy thing in this subject. All the other things that we are going to discuss in this subject is kind of like tougher. So now that we are here, okay, let's find the next term. Next term will be obviously 13.5 into 5 divided by 13.5, and which will obviously be 5. So I'm writing 5. Okay, now that we have written the whole Routh array for the particular characteristic equation given, now let us check the stability, whether the system is stable or not. For that, I'll check the first row of the given Routh array. And if all the elements in the Routh array, first column of the Routh array is positive, then we can say that the system is stable and all the roots lie on the left half of this plane. So we could say all, what I'm going to say is, since all the elements on the first column of Routh array is positive, hence we can say the system is stable. Okay, so we have found out the stability of the system with this question. Now we are going to do the question that we have written first, that is the first question. So we'll be doing that. I'm writing the question once again, that is s raised to 5 plus s raised to 4 plus 6s cube plus 12s square plus 18s plus 6 equal to 0. So I'm going to do this question. It is pretty simple. So I'm going to write the powers s raised to 5, s raised to 4, s raised to 3, s raised to 2, s square, s raised to 1, s raised to 0. Okay, I've written the powers in the descending order. What I'm going to do is I'm going to write the coefficients 1, 1 in a zigzag pattern, 6, 12, 18 and 6. Okay, I have written the coefficients. Next thing what I'm going to do is I'm going to find the terms in the next row. So in order to do that, I'm going to multiply 1 into 6, that is 6, and 1 into 12, that is minus 12, and divide it with first term, that is 6, that is 1. So I'll get minus 6 as the answer. I'll get minus 6 as the answer. Now in order to find the next term, what I'm going to do is I'm going to multiply 1 into 18, that is 18, and subtract 1 into 6 from that, and divide by 1, that is obviously 12, right? So I'm going to write 12. Okay, then we are going to find, is there any other term in this equation? If there was some other value here, then I could say there would be other term. Since there is no such value here, there is only 2 terms here. Okay, then we'll move on to our next row. So in order to find the value in the next row, what we are going to do is we are going to repeat the same procedure that we have done. It is minus 6 into 12, minus 12 divided by minus 6, and that value will be 14. So I'll be writing 14 directly, writing 14. Okay, I'll be writing 14 directly. Okay, then the next term will be, what will be the next term? Okay, I have something interesting for you. In the previous question, we have seen that once we did this and once we did the second multiplication and division, we noticed that the term here came here, like it's exactly the same. And similarly, this term after multiplication and division, it also came here. So from that, what you can understand is the last term in the column below, 2 rows below, will repeat in the next column. So what I'm going to say is, here if you do this, that is 6 minus 6 into 6 minus 12 divided by minus 6, the value will be 6. the value will be 6. So you can just directly write it without even doing it. Okay, if there is 0 here, just below the term, then you can directly write it as the term of the next row before the value. Okay, it's like a typical logic. You'll get it eventually. Okay, next is I'm gonna write the answers of the next row. So in order to do that, what I'm gonna do is I'm gonna write 14 into 12 minus 36 divided by 14. What I will be getting is the answer is actually 14.57, some kind of fraction. Okay, then there is no terms here, so there is only one element in the particular row. So next term, the final term, do you have any guesses what it will be? I have said earlier the same thing, 5 5 5. After each row it is like a pyramid, so like a side of a triangle, it's like going diagonally. So what will it be here? So it's very simple. It's 6 here, it's 6 here, and what will it be? It will be 6. You can just do it directly. Okay, now we are done with the Routh array. Now let's check the criterion for stability. I'm considering the first column. I'm checking the first column, whether all the elements of the first column are positive or not. So I'm considering the first column, checking that all the elements are positive or not. Here we see that all the elements are not positive. There is a negative term. That is minus 6. There is a negative term. Hence, we can say the system is not stable. That means all the roots are not on the left half of the S-plane. And on considering the fact that here there are two sign changes. By two sign changes, what I mean is this was positive 1 and it changed to negative 6. That is one sign change. And the negative 6 changed into positive 14. That is the second sign change. So there are two sign changes in the first column. So I could say the system is not stable or unstable, and two roots as there are two roots because two sign changes lie on positive S-plane, or we could say right half of S-plane. Okay, that's it. We have done two questions and we have understood what the Routh-Hurwitz stability criterion is. In the next video, I will be adding more problems, like some different ways need to be done in order to solve that problems. I'll be adding those in the next video. Please do watch it. If you like the video, please like and subscribe to my channel. I'll be doing more videos of control system as well as other subjects of electrical engineering. Thank you for watching.